Hello, everybody. This is David Janess, your host for a brand new series called Automation GPS. Know where you are, know where you're going. There's an awful lot of knowledge in the community, and this is an opportunity for us to start talking about it, to share it, and to make use of it. We have today started a new series called Automation GPS. And what it is a series that explores the strategies, the best practices for getting the most value out of automation. And there's two parts to it. There's the first Monday of every month, a 5-minute expert paper. And we have the authors today of the paper we published on March 6th on optimizing cloud and costs for cloud, most especially. That is the focus. And then on the third Monday, today, March 20th, we have an open Q&A, and that means open. You guys can come off mute and ask questions, or you can put your questions in the chat. I'm posting the article link in the chat one more time. I'll just keep posting it so that if you join late, you can get it if you haven't read it. What are we talking about today? We're talking about don't overpay for cloud, avoid these 6 common mistakes. It's called a 5-minute paper because it takes 5 minutes to read. Brian and the team have been succinct. It's impactful, and they're respecting your time, and it's a good read. And there's a lot in there that I think will inspire us today. What we've asked Brian and Benedict to do is present maybe 1, 2, 3 slides a little bit and kind of set up some stuff, but not take too long, and then we'll get right to it. But this is the first of a series, which means we have another one coming up next month, and that will be RPA, Robotic Process Automation versus Workflow. It's not either or, it's both. And if you've been attending our Automation Expose series, you've seen a number of applications that have both. And I think we're seeing more and more of that in the market. And we'll be joined by the co-authors, Stu Leibowitz and Brian Safron for that. And since it's a series, I want you to know there's a lot more ahead. Look at some of these topics. These are papers that are in the pipeline. Most of them are already completed, and there's more to come, but observability for cloud-native applications, integration, disaster recovery. We'll look at messaging and event streaming, application boundaries with microservices, and of course, regulatory compliance. That's a topic we certainly covered in the ECM world many times, and it's an important one. And so this is the kind of best practices and strategy that we need to get the most out of automation. That's what we're doing. Yep, we're going to take those entry tones out, Blake. I do them on purpose, so I know when they slow down, but we'll take them out so they don't bother us for the future. Right now, though, I want to introduce you to this topic today, and I'm very excited about it because, in an industry that has gone through many shifts in platforms and standards, this shift to cloud that's being experienced by many of our customers around the world may be the biggest one yet. And many folks are in the process of moving, they're planning on moving, or they have already moved aspects of their automation and infrastructure to the cloud. And so it's a very relevant, a very timely topic. We saw a lot of it in our user group meetings at the second half of 2022, and a lot of it in our online conversations. So very happy to have with us. Let me introduce to you our 2 guest speakers today. Benedict Fernandes, and in his career, he's been a computer science professor at the university level, a systems consultant, and he's logged 25 years as an IBMer in many high-tech roles. Today, he's part of this team that helps prepare the ways that we talk about this technology and bring clarity to these decisions. So we're really happy to have Benedict with us. And we also have Brian Safron. He's both a technologist and an award-winning digital media producer who brings both of those disciplines together in this particular project. His IBM journey has taken him through the worlds of Z, of WebSphere, rational decision management, BPM, and digital business automation, and that's probably just a little bit of it.
La noche, mamita.
All right, we're going to be
We're
muting people in the background,
dar chingos de
which
patadas.
is always fun. I'll keep on top of that, guys. And with that, I am very happy to introduce to you Benedict and Brian. I'm going to stop sharing, turn off the beeps, and why don't you start us off?
I'm Brian Safron, and I'm lucky enough to have a team of some of the deepest experts at IBM. And as we've been engaged with the products for many, many years. You heard Benedict's bio. And although I'm not going to be as eloquent as David, I think, because nobody can be, I think that we have a lot of, on my team, we just have a lot of insight into sort of some of the realities of the situation and of automation. And David came to us and said, we've heard from our user groups that cloud computing is not nearly as cost effective, at least in our bills, our cloud bills, as we thought it was going to be. So we said, okay, well, let's talk about that. Let's write something very succinct about how to fix that. And I was thinking about this. People call this a utility, but I think that analogy really falls apart, because if I plug a lamp into the wall, I'm not charged by the electric company. I'm charged when I flip a switch. But when I provision a resource on the cloud, I'm charged, and I'm charged by the minute for the entire time that resource is provisioned. So what we're going to talk about is what are strategies for making sure that you don't provision more than you need, for not provisioning resources and then leaving them as orphans, for scaling correctly, and for really timing the cloud so that you don't get surprised by your cloud bill. So again, Benedict is a deep expert, has been in this field way before cloud existed and then in the transition to cloud. So I'm going to turn it over to him and ask him to sort of walk us through his introduction. Benedict, all yours.
Yeah. So I'll try to keep this brief, right? As I said, we were trying to get into a conversation. So I think one of the biggest problems we come into when we talk about cloud is, at a high level, cloud is about optimizing consumption and optimizing the rate that you're paying for those resources. And it's a different mindset that people often come in from an on-prem mindset, where you provision resources, and engineers generally play it safe by over-provisioning because you already own the resources. So that's one of the biggest problems that we kind of see, that there's a side effect of a lot of over-provisioned resources. And then on the cloud, as Brian was saying, is you generally pay for what you provision, not what you use. So if you have an SSD that is lying around, you're going to pay a lot of money for it. Now, if you don't need the SSD, it's always cheaper to get an HDD. But a lot of people are now spawning up resources for experiments and POCs, and resulting in a lot of oversized resources, kind of unused Redshift clusters, for example. And some of these are pretty expensive. And over time, these idle resources kind of, add to the bill. The other challenge that we have is that the bill is very granular and opaque, and it's hard to understand. And often the people who provision the resource don't even see the bill. And the people who do see the bill don't understand the bill because they don't understand the technical side of things. So this cost management topic is unlike what we've seen before, right? Like, I personally have done a lot of performance tuning for some of the largest websites, and we never had to deal with cost. And when we had to deal with cost, it was an easy job because you just asked them to roll in more servers. And you'll always see a smaller utilization of those servers, but you never ever took cost into your engineering kind of decisions. So that's like a big mindset, be cost aware, in the cloud. And then, of course, it's like going into the supermarket now and you have so many things to choose from. AWS itself has, I think in 2006, they started with one instance, and now 15 years, whatever later, there are 475 instances of just one resource. And if you add all the variations of AMIs and tenancy and duration and the ways you can consume the stuff, there are over 1 million SKUs just for one service. So choice becomes difficult. And when you have a lot of choice, it's very easy to make the wrong choice. So that's typically some of the realities that we see on the cloud. One thing that is kind of subtle here is we've left out a lot of this industry surveys and all that, because I'm sure you can get that information in a lot of places. But generally, people see a lot of, like 30% of resources are kind of wasted. But more importantly, the topic of cloud spend has been on the CIO radar for the last 7 years in a row. So that in itself says that this is kind of an important topic for people. So in terms of the challenges that we have for cloud cost, it's on the consumption side of things, right? You want to use less because the more you use, the more you pay. So how do I use less? And the easiest way is to start identifying things that are idle, things that are unattached, not used, and look for opportunities there to kind of do some housekeeping and cleaning. And one thing that has not changed over the years is when you look at this, you look at compute, you look at memory, you look at storage, and you look at networking. And that's the same kind of framework you use when you kind of do optimization on the cloud. The additional thing that we need to add, which is actually pretty complex, is the pricing model. Now it starts off very easy as, oh, you just pay for what you consume using the on-demand rate. But what makes it complex is rate optimization. You could pay much less for what you're consuming. And in that simple statement of pay less, there's a lot of complexity and choice, right? Should I use this savings plan? Should I use a spot instance? Should I do a 1-year commitment? Should I do a 3-year commitment? Should I pay now? Should I pay later? Should I pay partial upfront? There are a lot of these choices, and all cloud providers, we're trying not to go to one cloud provider, but this is generally when you deal with the cloud, you're going to have these choices to make on pricing. And some people like to call it as micro purchases, right? Because now everybody seems to have a credit card. And so how do you try to centralize and try to consolidate and optimize at a central level, whereas the consumption is actually decentralized? So that is a challenge. And now you're paying on a per second charging model on a very granular basis, which we are not used to. So this is kind of, again, a difference from what we're used to, and we need to start kind of getting more familiar with the way resources are charged, and therefore cost awareness is becoming a more central part to the engineering process. And then, of course, as always, there's people, there's process, and technology. There's always, governance, which is like, what are the processes that we use to figure out some accountability? Like, you cannot do any optimization if you don't have visibility, if you don't know who is consuming what, which applications are consuming most of the resources, what type of resources. You cannot do any meaningful optimization. And what is a risk is, if you wrongly optimize, you could affect availability, right? So we had like a situation where one of the services was recommended for downsizing. It turned out that that particular service was very central to that whole SaaS offering. And by just trying to optimize a little bit of CPU and memory to shave off the cloud bill, they took an outage for a couple of days. So I think when you optimize, you got to also take into account risk. Yeah. So this leads to a lot of things, right? Where do I actually do these optimization exercises so as not to introduce risk? So that's all part of the process over here. And creating and enforcing cloud policies is some of these processes that are attached to kind of doing things the right way. For example, if you have discounts on a particular set of instances, then you want to make sure that your scaling is done according to those business constraints, because you've bought volume discounts on a particular type of instances, because as I said, there's 475. If you're compute intensive, you may need one type of CPU. If your workload is memory intensive, you need another kind of workload, another kind of infrastructure to support you. So the last point is like a catch-all, like so the lack of cost awareness in engineering culture, which is boils down to really being able to understand where the costs are coming from, right? So there's this field and a subfield, I would say, in cost management, which is about cost intelligence, which is very intelligent analytics around reporting and slicing and dicing your data in different ways so that you have the data to support any kind of optimization effort. But also there's an issue of timing here, right? Like in the sense, if you have a runaway, somebody's hijacked your EC2 instance and doing crypto mining on it, you don't want to know a month later, right? You can look at your bill on a monthly basis, but you want to be informed of these anomalies, these outliers earlier. So governance is also, as always in the past, it's like having a sense of what your baseline is, what your health is. And this is business as usual, because you can't tell if something is straying away from normal if you don't know what is normal. So there's this awareness of the behavior of your own workloads. You know, is it CPU intensive? Is it memory intensive, storage, network intensive? And then what is the normal behavior in terms of its metrics? And then one more quick point here is about, and we'll get to this a little later, probably in the conversation, is this nirvana around the cloud bill is always going to go up. So just saying minimizing your cloud bill is kind of a controversial thing, right? Because and it depends how you interpret, because the cloud bill is also going up. The question is, how are you getting the most value of your cloud bill? How are you ensuring that you're not wasting the cloud bill? So it boils down to optimization. And when I think of optimization, I think of balancing performance and price, right? Availability of your applications and workloads is the most important, but how are you doing it at the best price? So this is the last slide, and then we can open it up for conversation. So selecting the right resource type is kind of, the first thing. As we said, right, if your database optimized, if your memory optimized, if you have a gaming app, you can choose the particular type of workload. And this actually brings a very important thing, because the cloud service providers are introducing a lot of capabilities. So there's a lot of constant change. If you make a decision today to use a particular type of instance, how sure are you that actually there's nothing better to run your workloads in the next few weeks? Because there's constant change. Then there's change on two sides. There's change in your workload, the way users are using your workload, and there's change in the offerings that are coming out from the cloud provider, right? And the cloud is doing a lot of innovation, right? Today, AMD processors from 2018, I think, were introduced, offer a much better price point than the traditional Intel-based processor. If you're doing machine learning and doing training and inferencing, you may want to use GPU-based machines. If you want to do more acceleration, you may want to use accelerators, because if you can cut the time, you're going to get better value. And just to throw in sustainability, ARM processors are kind of very attractive there. But the point here is that there are many choices. Choosing the right type of infrastructure to support your workloads is kind of important. The second point here is around managed cloud services, and I put there like DIY. When we come with the on-prem mindset, we want to install and config and lay up the whole stack ourselves and bring these enterprise licenses. So the thing to be aware of here is that as you go to the cloud, you want to stay away from the do it yourself, because there's a lot of hidden costs, not only in the licensing, but in the disaster recovery, the reliability, the availability, the serviceability, the ability to get insights into the workload. And the most important thing is a labor cost. When you have to set up an Oracle database and make sure it's disaster, has all the attributes for high availability, it's a pretty expensive exercise. But if you can do it by the click of a button using a managed service, the ROI is much better. So that's why it's better to, when there's an option, move away from proprietary licensing to a more open source managed service. And that's a very high level point, but there's a lot of detail, as you can see underneath. Know who is using what, right? And something that's not evident here is, again, going back to the point of risk, is if you think of a pyramid, the production workloads are normally 20 to 30% of your total cloud usage. You could have dev, test, and there's 5 to 8 environments in these non-prod environments. Those are the best places to introduce change, to learn, to iterate, and to test, right? Because that's where you get the most, is the least riskiest. And if you're in Brazil, you don't have to spawn up an instance there. You could spawn up an instance in US East if you're willing to tolerate a bit of latency, if you're able to. You get much better price point here than in some other geos. So optimization, as you can see, is a complex thing, right? But there's a lot of factors to balance price and performance. And you don't always try to get for the best performance. You always try to get for the best possible performance at the best available price. So especially that applies to dev test workloads. And another thing that's becoming popular is cloud parking. People call it instance scheduling, where you kind of, a work week is 24 hours a day, 7 days a week, but there's only 40 work hours, which is actually what, like 23% of the time workloads are needed by dev. So 70% of the time you can turn those off. So those are things to kind of think about in terms of turning off resources, which we are not used to when we come from on-prem. And as I said, there's two parts to the equation, right? Consuming less by turning off and by right-sizing resources. And for the resources that you actually need, how could I pay the least possible price, right? So that gets into reserved instances and spot instances and auction-based pricing and leveraging programmatic discounts because things come at volume. And then another subtle thing here is people like to do multi-cloud. You want to do a little bit on Azure, you want to do a little bit on GCP, you want to do a little bit on AWS. But if you add it all up, it's like a frequent flyer, right? Sometimes if you get status on something, like you're spending more than $1 million on one provider, you probably get better discounts on one, right? So these are things to take into account when you're doing pricing. And often the guys who do the pricing can only go so far because they cannot go to the engineering team and tell them optimize this. Sometimes that could be, become a long drawn kind of exercise. So you got to work at multiple angles on consumption and on pricing and do them all in parallel and also try to drive collaboration, because the good thing is you have all the data. And the last point I like to make before we open it up for conversation is, as you can see, there's so many moving parts, right? In terms of choice, in terms of the way you design things, you got to have some kind of automation in terms of discovery. Like, can you go and plug in and check all the resources that are provisioned in all these accounts? Sometimes you would never know because a team has come and gone and you would never have any insight into some of these resources that have been provisioned for a POC and then just lying around. And the teams may have shut, the people may have moved on. So there's a bit of discovery, there's a lot of analytics, because the discovery will give you the visibility into the technical debt. It will identify things based on usage, right? So this concept of M&M, right? You need to monitor and measure, because unless you monitor and measure, you would never able to know what's your baseline. And then there's the analytics that are applied because of the change in your workload, in your usage pattern. And then, the ability to kind of find out what are the best ways to run this workload. Having people run around with spreadsheets, it's not scalable. The knowledge is not there. It's very static. So it's very clear to see that you really need a new set of tools. You need some automation to actually do this process properly, right? I think there's a Chinese saying, don't get into a business if you don't have the right tools. And I think this applies a lot here. Like if you're into cost optimization, it's hard to do it without any tools. So there's a lot of other stuff to go on, but I kind of want to keep it open for conversation. I think one thing that is kind of missed here is the complexity of the cloud, right? Like if you take an application and you want to lay it out on a network, there are a lot of hidden costs that may show up on your bill that you may not even understand, because point A and point B are talking to each other. You don't even know why you're being charged. It could be across availability zones. It could be across, VPCs. You could be going across public IP addresses. So there are ways to optimize each of these things along these 4 axes, right? Around compute, around memory, around storage, and around network. That's where I would start. Of course, there are other more specialized things. And so I would say that's where I would open up for questions.
It was only a couple of years ago, Brian, that I began to see the term FinOps, which I think in a way, this is what we're talking about today. And one of the questions that came in is this a lack of education or a lack of knowledge on cloud? Is this problem coming from that? And I think that's exactly where it's coming from. And it's conversations like these that need to happen, right?
Well, right. So we could have used the term FinOps many times here. We didn't use it just so we wouldn't get buzzwordy with it, but it absolutely applies. I don't think, as Benedict pointed out, engineering doesn't have a cost culture. They don't understand, these line items, they're just used to making sure that the application runs, making sure that you don't have an outage, making sure that the performance is good. And that culture is not there. And they were so surprised by the cloud bill that just kind of expanded by 10% a month, 20% a month. It just jumped, it leaped. And I think that, that's where FinOps came from. A financial approach to operations, because this has now become as much an economic thing as it is an operations thing. And all of a sudden, operations teams have to deal with this reality that, they didn't think they were part of the quote problem, the cost problem, and now they are. And they have this super complex sort of criteria to deal with, and that's not their, they were trained to make applications work. So how do you get this sort of understanding of economic sort of realities here, and how do you get this teaming and this collaboration to bring the engineering folks with the financial folks, because that's not really a natural pairing. So absolutely, FinOps is right down the middle of this conversation. Benedict, do you want to chime in?
Yeah, I just want to add one small thing. Like when you see these 2 words like DevOps or DevSecOps and FinOps, these hyphenated words, typically it's about breaking silos in teams. It's like trying to drive a culture of collaboration. And I think that's what FinOps is trying to do, right? Bringing in the cost discussion into engineering and bring these 2 people together, because the guys managing the spreadsheets, doing the central procurement, are not familiar with the engineering side, and the engineering guys don't care about the cost, but the CIO cares about the bill. And so, but if anybody else has anything to add, then,
I think that's really smart. There are folks on this call that have been through the whole cloud process, and if they had some answers to some of this or some experiences to share, we would love that. Otherwise, we'll keep on going with the. But come off mute, put your camera on if you like, and contribute. But we have a question from Paul here, which I thought was also interesting. That the cost varies by geographic location, and that was news to Paul. I think it's certainly interesting. And how do you find out about the cost structures in your various geos, and how do you plan that way?
So most providers have a very good, they call it calculators, right? So if you go to calculator.aws, for example, and even IBM Cloud has it, Microsoft Azure has it, everybody has it. Go to the calculator, and then you start playing around with it, and you can see same CPU and same memory configurations, how they can be different from Intel to AMD, how they can be different from Virginia to Mumbai. And those variations you can easily see. And if you're doing the exercise, there are some very good learning. So sessions on how you do these analysis. But yeah, calculator is something I would I would use. Yeah.
That's
And
cool.
David, I think we could add to that is there are so many variables here. And, you know what the goal is. You know the goal is meeting the SLA, and that's going to be different if it's production versus test, and doing it at the most cost-effective way. So because, for example, software integrates directly with AWS, directly with all the cloud providers, it actually has access to all that information. It knows Virginia versus Mumbai versus wherever. It's too much for people to actually go through and sort of parse out, but it's not that hard for software to do it. So this is a real argument for, using software which is integrated directly with the cloud providers to sort of understand that. You tell it what latency you can tolerate, you give it parameters, and then it's just an optimization problem. It can sort of take all that data, millions of SKUs, all these geographic locations, and say, this is what we recommend. And that's invaluable.
Nice. I always leave a pause in case anybody wants to jump in, but nobody jumped. In your paper, which I've put the link in many times, there's 6 sort of big mistakes to avoid, and one of them is over provisioning, and you've talked about that quite a bit, and it's on this slide as well. But how do you track resource consumption? I mean, what are some of the ways that people are doing that?
So most of the cloud providers have tools for you to track the usage of CPU and memory. And so either you can use that directly, or you have third-party tools that kind of leverage those metrics. But end of the day, whether you use APIs, whether you use any other source of it, it has to be driven based on historical usage. Yeah. So it's basically CPU, memory, disk, and network. Again, the same 4 things which we've always been using. Because if the tool has to make a recommendation about any of this, it has to know what resource is constraining for the workload at hand, and how much I/O am I doing, so that I know if this is I/O intensive, then I recommend this CPU instance because that has the capacity to support this storage bound kind of, if it is a database kind of workload, it needs an SSD. If it's a batch workload like running Hadoop, maybe I could get by with the cheaper HDD. So those is basically, you really have to. It goes back to M&M. You go to monitor and measure.
Yep, that's why I was trying to get into the how.
Yeah.
You brought up something called auction-based pricing, I think, on your 4th point here. And so, What is that? How does that work? Who's auctioning?
So I think there's a question here, but I can answer this, and we can go back to the question. Okay. So this is a very interesting thing, right? So it's about, you have steady state workloads. For the most part, your production workloads will be steady state. Maybe you're running some batch workloads during a window. But there are some workloads that are spiky, which are, let's say, traditional big IBM enterprise workloads. 3 weeks of the month, it is busy. The last week, it gets busy. And then we have Black Friday sales, which can peak. And we generally size to that. The newer way is actually, and this again goes back to on-prem versus cloud mindset. You don't size for the peak. You size to leverage elasticity of the cloud. So you have smaller chunks and then allow it to grow and scale up and down. Don't try to size huge chunks, because then that results in waste. So have smaller chunks and then put it into auto scaling. So when a particular metric is going up, the platform will manage capacity and demand automatically. And for the most part, you can run your steady state workloads under on-demand pricing, but that's expensive. So since you know what it is, it's predictable, you run it under discounted pricing like savings plans. And that would give you a 70% discount. There are workloads like election day or auctioning, or there was a big cricket match in India where I think it had the most volume increase in a particular day. It went from 3 million to 16 million users because somebody was batting, and there was a huge game between India and Pakistan. And the guy was showing how he used spot instances to manage those kind of very spiky workloads. And there are ways by which you could pre-allocate and price and put an auction price, but you could get those instances at about 90% discount. So if your workloads are fault tolerant, ability to handle failures, like simulation, I can run a simulation. If I get knocked out, no worries, I can carry it on later. I can resume my state, carry it on, but I'm running that at like 90% discount in the background. So that will give you the most discount. Does that answer your question, Dave?
Well, I'm getting ready to take an 11th grader to college, and studying, how to pay for college sounds just about as complicated as how to pay for cloud with all the different variations and variables. How do successful companies, manage all of these different variables? Do they just say somebody is in charge of our financial relationship with the cloud provider? And what are those ways to be very practical about it?
Yeah, so again, it goes back to tools, right? So first of all, you need to understand what you're using. Then this is an extremely interesting point because there's a new tools on how you manage your reservations. Because if you buy discounts, again, if you don't use it, you're going to lose it. So you want to make sure that you buy discounts. It's like when you get paid dividends, you don't get paid a lot of dividends in 1 month. You want to spread it out over like the year. So you do your acquisitions of these discounts by quarter, for example, and you track whether some of them are 3 years, some of them are 1 year. So basically, it's not only visibility into performance and the technical side of things. There's visibility into the pricing, the discounts you have, the consumption that you have, so you can negotiate more discounts. Beyond all this, there's enterprise discounts that you can negotiate with the cloud provider, and then plug them into the platform and or some kind of third-party tool where it helps you to track these things. People are using spreadsheets today, but that's a big nightmare job again, because you're having people running around, people leaving, and you have to hire people to run spreadsheets. So if you look at the total cost of doing that, it's kind of expensive. So,
well, let's get into tools.
And let's go back to the question of reserved instances, because 70% discount is enough that if you don't use every bit of it, you're still much better off. So when we wrote the paper, we really sort of looked at what the curve looked like and how much forecasting you had to be able to do and how close you had to come to using, the vast majority of those reserved instances. And because the discounts are so cheap, it really comes out that most of your workload should be on something that's discounted, because the pay-as-you-go price is just so high. It's like if a hotel room had a $1,500 a night pay-as-you-go price, but if you reserve just enough of it, you could get it for, $100 a night. And so I think it's important that you kind of look at your workload and put everything you can into discounted pricing.
And one more quick point is like my discovery, right, and others can share their experience, is that everything is so complicated, requires a lot of deep expertise, because if you don't have the knowledge, you won't be able to optimize, right? So you have to have the knowledge of what it is, what exactly how this works. You need to have understand what the best practices are, and then what tools are there to help you to kind of actually do this in real life, to operationalize this whole auction-based pricing. So, there's things that there are a lot of advisor tools that kind of help you along the journey. Yeah. And there are also like best practices on, for example, if I'm putting a price, I could put a price just below my on-demand price, or even put my on-demand price. The worst case, I know that I will get to an on-demand price, but I'll always use a spot instance if it's available, right? So, smart. Yeah. Okay. Did Paul have a question?
If anybody wants to come off mute, please do.
And I don't want to belabor the point, but we're hearing more and more about folks offshoring their data in their data centers. But how could they justify offshoring it if, as you mentioned, Brazil is more expensive than the US? I mean, obviously I'm misunderstanding something.
Yeah. So I think offshoring means your people are there, right? But you can provision anything in any geolocation. That's the whole idea of cloud. It has this geographical network where the point of a click, you can go and provision an instance in another geo, right? There's nothing stopping you from setting up your whole kind of infrastructure in US East, if it makes sense for you, especially if it's dev test. If it's production, You want it to be closer to who's consuming it. And then you want to be sensitive to geolocation. Um, so it's, yeah. To take it even further, right? I mean, there are ways to optimize that from a technical perspective, because there's whole local zones. There's ways to cache stuff closer to the user, but that makes sense for mission critical workloads. So
We started talking about tools, and a question came up about, do you think Turbonomic would be a good tool for this? Now, you guys have been very sort of agnostic in terms of product in your best practices writings, but let's talk about those kinds of tools.
Sure. So first of all, we recognize there's a necessity for tools. A lot of the cloud providers, most of them, naturally offer tools for their platform. But of course, they don't go across clouds. They kind of depend and they for only their services. A lot of them are, of course, also they charge for those when you go above a certain volume. So you have the choice of using the cloud native provider tools like Trusted Advisor, and let's say we didn't even talk about code. You can do like a code X-ray or Code Guru. You can kind of look at code optimization. You can use a cost explorer. You can do EC2 instance, a scheduler. There are a lot of things that you can do on the native cloud provider. Moving towards a more multi-cloud approach, some people prefer to have tools that are agnostic of the cloud provider and give you like a unified view. Now, you don't have to use only Turbonomic, right? You can use Turbonomic with a collection of that, and it's never one tool, and most people have multiple tools. But the idea is that for you to quickly get insight into, let's say, a geographical distribution of workloads, what is GCP, what is Azure, what is AWS, Turbonomic will provide you very good tools. Let's say you have a very big, the CIO comes and says, oh, the bill is very high. The first thing you want to do is to identify low-hanging fruit. What can I delete? What is oversized? What is the risk? How many discounts do I have? How do I manage that? This gives you a quick view into these things at a very, I would say, like a fast rate, as opposed to you trying to stitch this together manually from different cloud providers. So that's the advantage. And typically the third-party tools have a lot more analytics, and they have a lot more observation period. So they provide those enterprise qualities of service that would often be lacking from a free tool from a cloud provider.
Nice. And I see Vicky put in an experience that she had that the customer wanted to turn off some things and then turn them back on again, such as their Kubernetes cluster. But that may be risky too, in that it doesn't come back up the way it was properly. Have you seen that?
So there's turning off and turning on things, and then there's this whole idea about Kubernetes, and we didn't even touch Kubernetes here, right? Because, and again, the way I like to think of it is you have an application never runs on the kind of the bare metal providers these days. It runs on a platform, and you have the virtualization platform like vSphere. You have a cloud platform like your AWS and Azure and everything else, and then you have a distributed kind of platform that gives you high availability like Kubernetes, right? So you have your application, now you're running in containers, and the reason you do that is because you want to modernize your app to a cloud native so you can scale up certain parts and you get the high availabilities of the platform and everything. So that's good. And it's better if you use the managed Kubernetes service as opposed to setting up your own thing. Now, there may be reasons to set up your own on-prem and even on the cloud, your own cluster because of security, and that's fine. But I think there are three issues with Kubernetes. One thing is container oversizing. Though Kubernetes provides all these qualities of service, Kubernetes has no way of telling you whether a container is oversized or undersized. It just takes your container and it finds a place for it to run. If it fails, it moves it somewhere else. If there's overcommitment of memory, it may kill your pod and may send you somewhere else. And so container oversizing is one thing. Once a pod is placed on a node, Kubernetes does not do anything today. That may change, but it does not move it, because when you place it on that node, it may not be the best node to always run your workload, because other workloads have come in. Maybe somebody was there, did not size his container properly, you have a noisy neighbor issue now. That one guy is taking up all the node resources. So it could starve your guy or your container. And the third thing is around intelligent cluster scaling, that it's not easily done depending on the version of Kubernetes, right? But the point about bringing it up and bringing it down, it goes back a bit to the design issue around stateless and stateful. Obviously, stateless workloads work very well because I can bring it down, move it anywhere, and it kind of starts up from scratch. When it's stateful, then yes, I need to worry a little bit more about how do I restore the state and then restart the container. And most often that's maintained in a central database, which is kind of failed over, or it's like starting a batch process. I'm running 1 million records in the night. I've now crashed at 770. How do I start from the next one? There's always failover built into the kind of the application frameworks typically. So when you're dealing with stateful workloads, it's the complexity is in the code of how do I get back to the state that I last left off. Yeah.
I like it. We've gotten deep into it. We've gotten into acronyms and some good technical conversation here. We have about 5 minutes left, and you could submit a question in the chat here or come off mute, as our good friend Paul has done, and just ask the question. We'd love to have you be part of it here. Just going through to make sure. There's a couple of things about AWS that were brought up. I don't know how knowledgeable you are about, in particular, AWS. Benedict, but certainly some talk about AWS instance. What are the recommendations for CPE, ICN, CSS, WAS deployment with containers, without containers? Is there a best practice there, or is that really it depends kind of an answer?
Well, so it always boils down to what workload is running in that container, right? Like in WAS, I could run WebSphere, I could run, CPU intensive stuff, I could run batch stuff, I could write queuing stuff. So the resource that you choose depends on what is running inside your container or what workload you're trying. If it's a transactional workload, is it a batch workload? Yeah. But I think the broader point here is around, which we didn't get into, which is around modernization. And I like to take the broad generic term, but it's around modernizing the way, always look for the best place to run it. And today I may choose an M56, an M6G, tomorrow it may be something else, and that's why you rely on tools like Turbonomic to constantly advise you that, what, you're running this workload based on what I see, I think this is a better place. So these recommendations, whether they come from tools like Trusted Advisor, or I think Turbonomic is very powerful here, to give you these recommendations. So things that you may not consider comes to you. So now, and I have many examples like this, but given the time, we can't get into much of them. But the other is around, as I said, about managed services, right? So you get into managed services, take out your enterprise expensive licensing. Like, you don't need Oracle licensing. They have tools to take that schema and convert it to Postgres. They are free tools. Use those free tools, and now you have high availability disaster recovery, and your full stack is priced at a much cheaper price point. It's not only the underlying infrastructure, it's your application, it's everything else, it's the licensing all the way to the top. Yeah. And then of course it's the networking costs that you kind of need to worry about. Maybe I can use serverless, and go from traditional architectures to cloud native architectures. And then of course there's the whole thing about governance, which gets back to the tools. So no matter what I'm doing, I need to have visibility. It goes back to M&M. I need to monitor, measure, and then have some dependence on some analytical platform that can do this automatically for me, so it can scale. Because I'm running, most customers will now start having like hundreds of containers running, right? So how do I do that in a more automatable, scalable way? Yeah.
Interesting. Jean de Pommier, thank you for, I saw you pop up there, and you can come off mute if you like and flex
Sure,
out
yeah.
your point.
Well, it's an opener for for another session, but I do think we say too much the cloud when, us, but also our customers, and so many people think of one thing when they they say the cloud. They have an option in mind, and so on our side in business automation, we have to take into account very different usage. So it's I mean, who wants to spin a process server? I mean, all over the place. I mean, so it's something that has been built to be centralized. So that's one of. But yeah, well, I mean, workflow services. They are meant to be like spin very easily. So we want to educate people that all these options exist and it's not one or the other or black and white. And so for me, David, it's what's really essential here is that we take into account the life of a content manager, the life of someone administrating processes, and I think Benedict and Brian said it. It's this dichotomy between people who have no clue what's running, and so we need to find the right balance. Okay, so it's very important that you understand what's up and who that does serve and for which purpose. So the cloud definitely brings the innovation. I mean, the way to start things very, very fast, either on SaaS or on many other options that we provide. So cool, yeah. Cool topic.
Thank you for that. We have, reached the top of the hour and it went by so fast. I want to thank Benedict and Brian for their expertise, their knowledge, for prepping this, for writing a great paper and getting this conversation going. I know it's going to keep on happening, this conversation, but to really take a close look, a focused look at cost optimization, I think is very helpful and beneficial to our customers. So again, I want to thank Brian and Benedict. I have recorded today, and we've got the 3 slides from Benedict, which we can make available, which I will do so once the recording is ready. And this is going to be an ongoing conversation. I'd love to see in the community some thoughts, some reactions, some comments from any and all of you. And this series will continue in April. We're going to look at RPA versus workflow. It's not either or, it's both. Any last thoughts or words, Brian or Benedict, that you'd like to end with?
Yeah, there's a lot of stuff we never covered, but feel free to reach out to us, and if you want to follow on session, we could definitely do that. Yeah.
David, thanks for setting this up. I think this was great. I love the format. Benedict, thanks for bringing your expertise. And I think we should just keep doing this and just keep sharing these ideas. And we're going to keep writing these really tight papers where we get right down to business as opposed to 15 pages of stuff that people don't have time to read. So thanks, and thanks, David. Thanks, Benedict.